So today our discussion is a very thrilling one, which is about a milestone as we prepare for a 15 kg PCI leap. So we are not just adjusting a dial, we are embarking a systematic optimization of our high capacity furnaces. So our goal is to synchronize an activity-wise timeline that pushes our operational boundaries while maintaining a healthy and high performance reactor, vessel or blast furnace that we can name. So now coming to a systematic phase shift, which is about moving from a baseline of 135 kg per ton hot metal to a target of 150 kg per ton hot metal is a actually a profound systematic phase shift. So as we increase coal, the volume of our skeleton metallurgical coke decreases as a fundamental everyone knows. So which fundamentally alters the gas permeability and heat distribution also, and most of the time when we also do we must have to consider these both aspects. So our mission is to sustain output while mitigating the risk of lower permeability and hearth accumulation through a strictly controlled multi-week transition. But how do we stay balanced? That is a really big challenge, and this is also very important to address the higher management while making a shift. So we use our counterweight like in the subsequent slides the approach is shown. So mastering the threshold imbalances, we can say, by adding that extra 15 kg per ton hot metal tips the thermodynamic balance we have to find out. So we face increased gas volume from the rapid devolatilization and a drop in theoretical flame temperature, which is quite obvious because the coal increase is also act as a coolant. To counter these, we will deploy three critical counterweights. One is the oxygen, as it shown in the slide very clearly, which is around 4.5% to 5.5%. Center coke charging, which is a pretty standard proven technologies, is being adopted by all operators to preserve our gas chimney and elevated blast temperature to 12 around 1200. So this total system approach is managed across four interconnected domains. And what are those four interconnected domains? Those four interconnected domains are uh, mm, or we can say that to succeed we must harmonize these four interconnected domains. These are the blast and combustion dynamics number one, body and gas distribution number two, raw material integrity number three, and hearth management, which is supposed to be very important, is number four. So these domains are the gears of our furnace. So if one slip, the whole system fills it. So let's look at our first pillar, the fire in the raceway. That is pillar number one. So pillar number one says that combustion rule of thumb says that our combustion dynamics are governed by rigid rules. We must strictly maintain a target draft of 2200 to 2300 max to ensure complete burnout of the higher coal volume. So every 5 kg per ton hot metal increase in coal, we will implement a 0.2% to 0.3% oxygen synchronizing rule. So we will also push our kinetic energy K value upward to maintain raceway depth against the heavier material flow descending from the above, and this leads us to how we manage that material flow. Now it's coming to the pillar number two, is about a structural body integrity. So at 150 kg per ton hot metal, the coke layer or only solid structure in the melting zone shrinks significantly. So to the fight this, we will deploy center coke charging to maintain a highly permeable chimney for ascending hot gases. Simultaneously, we will use advanced multi-ring program to fine-tune our ore by coke ratio at periphery, protecting the valve while pushing gas towards the center. So, of course, these strategy only work if our raw materials are up to the task, and that is to be kept in mind. That is is to be met properly. So, coming to the material integrity tolerances and details, we can see that high intensity operation uh, demand uncompromising material quality. We are elevating our coke CSR strength after reaction from 62 to 65 to prevent mechanical crushing under denser ore burden, or you can say due to the ore burden column load. We are also tightening our center fines less than 5 mm to below 5% to prevent cohesive zone blockages. Additionally, we will optimize our MgO by alumina balance to maintain slag liquidity despite increased coal ash. So this liquidity is vital for our next pillar, the hearth, and this is pillar number 4. And as we know, this is about a hearth and liquid drainage. So we must prevent catastrophic tear flooding by ensuring our liquid drainage capacity stay ahead of the higher slag volume generated. Our central deadman must remain highly porous. We will mandate the strategic use of coke blanks, pure coke charges to refresh the lower zone and flush out accumulated fines. So this stabilization of upthrust gas pressure is our primary defense against erratic burden descent. So mitigating this unburnt char threat, we must stay vigilant against unburnt char, which can permanently block our deadman. Watch for the warning signs like spikes in the top gas carbon. We have already discussed in our earlier presentation, unexplained pressure drops, our darkening pip sides. So if detected, our immediate countermeasure is to adjust the stoichiometric oxygen ratio upward and forcibly restore flame or raft minimizes to ensure complete gasification. That is, if we keep on increasing, the oxygen enrichment or flame also goes on increasing, but there is a boundary where we have to take a stop. Otherwise, our softening and melting will be drastically affected, and wind acceptance will down, and this will be totally against the PCI injection project. So precision is everything, which is why we use a phased approach. So the phased approach says that uh, we do not rush excessive. We phase it. Step 1 is the baseline stabilization to ensure drainage is flawless. Step 2 is the incremental synchronizing, where coal never increase without its masked oxygen synchronizing rigid 3 to 5 kg per ton hot metal in steps. Step 3 is concerned, as far as step 3 is concerned, gas turning to manage new pressure drop, followed by long-term monitoring where we hold until silicon and metal temperature fully stabilizes. And this type of this quantum jump is only going to make your success story of leap of 15 kg per ton hot metal. Now coming to the 12-week our master timeline program, as it's shown, our 12-week horizon is a disciplined march. We will execute 5 kg plus 0.3% oxygen synchronization at week 1, 5 and OFIC 1, 5 and 9. Following each adjustment, we tweak our central coke charging and enter a hold and monitor period of track, hot metal, silicon and tap temperatures. We need to more focus on this, that what is going to happen. It is not about only increasing the coal injection. With the coal injection, what is the after effect is coming, we need to evaluate very closely. And this timeline ensure we look in our supply of high CSR coke and low fine sinter before every leap, which is very important to create our success story. So we must respect the 7 to 10 hours thermal lag between a cold change and a hearth response. This is most important, and we need to know that minimum response time of any PCI injection is almost 5 to 6 hours. So once we take a action, we need to stop further. Otherwise, it may create a problem. For example, let us take an example of lower silicon, and we are enhancing the coal to a suppose 5 kg. So we need to unresponsive till further action, if unless until the silicon is in a very pathetic boundary like zero point 0.2 or something like that. That might be a panicky situation, but unless until our deep is lesser, we need to follow the thermal effects very patiently. So if we detected drop in cohesive zone heat, we will immediately decrease wind volume and adjust peripheral coke. So if thermal oscillation is detected, we use short-term oxygen adjustment first, never aggressively swing long-term coke rates. So if permeability resistance spikes, we hold PCI and verify our center coke chimney integrity. So this type of patient activity is very much important. Now coming to the balance reactor. So in summary, we are not just turning dials, we are mastering the thermal blueprint. Through precise center coke charging and gas chimney management, we achieve operational stability and permanent metallurgical coke replacement. This initiative ensures sustained economic impact and campaign longevity for our furnace. And this is going to be a nice yardstick to experiment of 5 kg increment or 10 kg short of increment. Definitely, this is going to pay you a positive results.